everyone, thanks for coming to my talk. I am recently at the UBC Okanagan now, just defended my PhD from Sheila Colla's lab just over a month ago, and the work I'm presenting here is one of those chapters, and it's recently submitted for publication too. It's looking at conservation planning for native bumblebees under current and future climate scenarios. Okay, my screen does not want to, there we go. This is a little bit delayed. All right. So current protected areas may not be that effective at conserving biodiversity. And that's because protected areas are usually picked in areas with low resource availability for extraction for industry, for example, and they're not necessarily considering the most biodiverse areas or the areas with the most at-risk species. A potential solution for this is something called systematic conservation planning. So systematic conservation planning is a way to systematically plan for conservation areas that are more effective at conserving biodiversity while considering costs to keep costs down. And it can be incorporating different goals for conservation, such as trying to increase the most at-risk species or just the most species, period. And it has explicit methods throughout this process so that it can be replicated and it can be easily defendable as well. And the results of this process gets protected areas that should be efficient and effective at conserving biodiversity. Climate change should be considered with any conservation planning program because obviously with climate change, temperatures are warming, precipitation patterns are changing, so species ranges are likely going to shift. And this is already happening for bumblebees. We see that there's decreased occupancy in areas where there's more warmer temperatures and decreased precipitation. And bumblebee ranges are shrinking, usually in the southern end of the range without bumblebees moving as far north. So that brings me to my three research questions, which are where are bumblebee conservation priority areas now and into the future across Canada? Do conservation priority areas change with different objectives or different conservation goals? Are conservation priority areas within current protected areas? So the priority areas for bumblebees, are they already in protected areas? So I have a little schematic of my methods here. So I made species distribution models using Maxent for current and future climate scenarios. The different climate scenarios I used were RCP 2.6, which is the significant emissions reductions from now, and RCP 8.5, which is the highest emissions scenario or the business as usual scenario. And then I took these species distribution models, and these were done for all bumblebee species found in North America. And I ran them through a program called Prioritize-R, which is a systematic conservation planning program for all of Canada. And I did this for two different objectives. The first objective is minimize costs, which aims to maximize the amount of biodiversity conserved or the number of bumblebee species while minimizing the cost of the solution. And the second objective was to maximize phylogenetic diversity while staying within a budget. And I did this for three different conservation targets. So 17, 30, and 50% of each species range to be conserved. And the cost that I used was the area of Canada. And from this, we get our conservation priority areas. And today, just in the interest of time, I'm only going to present the results for the 30% target. So here are some of the results of that modeling. This is a map of the conservation priority areas for bumblebees across Canada. The brownish orange color is for current climate, and the blue is future climate. And the future climate for this one is RCP 2.6, or the lowest emission scenario. And we see that Western Canada, Southern Ontario, and the Maritimes are most often prioritized for bumblebees. And with climate change, the blue, we see that there's a shift in higher elevation areas, and there's a shift in increasing latitudes, or shift north in latitude. This is the same objective, sorry I didn't mention the objective, the minimize cost objective, but now for RCP 8.5, so the highest emission scenario. And again, brown is the current climate, and blue is the future climate scenario. We have very similar ranges or regions that are conserved, or the conservation priority areas for bumblebees. We have, again, Western Canada, Southern Ontario, and the Maritimes. There's just a much more pronounced shift into the northern regions and into higher elevation areas. Interestingly, this is the maximum phylogenetic diversity objective for the lowest climate scenario. There's similar regions that are protected, which are good. It's just a little bit more of a shift into the southern regions here. And with climate change, again, there's a shift north in conservation priority areas and into higher elevation regions. Again, this is a max phylogenetic diversity objective. We're just with the higher climate emission scenario. We have the same regions that are prioritized, just there's even more shift north and then even more shift higher in elevation. Another thing I want to point out is a lot of the conservation priority areas are located in these highly densely populated regions of Canada, mostly concentrated in the south, where a lot of people live and not as much area is protected. We also combined the solutions between current and both future climate scenarios to see which areas were consistently prioritized. And we see, again, that Western Canada is consistently prioritized across both objectives, regions of Southern Ontario and the Maritimes. When we compare the conservation priority areas to current protected areas, we see that very low percentages of our bumblebee conservation priority areas are already within protected areas. So our protected areas aren't doing such a great job at conserving areas for bumblebees. This graph shows all the bumblebee species included in the models and the effect of climate change on their percent area that's greater than 50% suitable with climate change. So blue here is current climate, yellow is RCP 2.6, and it gets hotter with RCP 8.5, so I made it orange. Any of the species with a star beside it is a species at risk. So we see some species are actually going to increase their habitat suitability with climate change, and a lot of these are our eastern species and species that are not at risk. But more species are going to have a decrease in their habitat suitability. These are mainly western species and species at risk, which is concerning. And we have two that basically remain the same, and they're both at-risk species. So to answer my research questions, where are bumblebee conservation priority areas under current and future climate scenarios? The Western Canada, Southern Ontario, and Quebec, and the Maritimes are areas that should be prioritized for bumblebee conservation. And the conservation priority areas for bumblebees are going to shift north and increase in elevation in the future. And do conservation priority areas change with different objectives? Very similar areas were selected with both objectives, which is good news because you can conserve the same similar areas and achieve both maximizing biodiversity and maximizing phylogenetic diversity. And are conservation priority areas within current protected areas? So the answer is no, not really. The highest amount was about 13% conserved, which is not very good. So a lot of areas that are priority areas for bumblebees are not protected. So in conclusion, bumblebee conservation areas need to plan for future climate change impacts. So we can't just protect areas now because it's going to shift in the future. And because current protected areas are not conserving bumblebees, we need to engage private landowners specifically to help conserve bumblebees. And one good thing about bumblebees is they can exist in many different landscapes. So it could be pretty easy to get private landowners on board with increasing habitat suitability for bumblebees by planting pollinator gardens, not spraying pesticides, for example. So that's one advantage for bumblebees, in that they are located in such highly populated areas where it might be very difficult to form protected areas, for example. And the identified priority areas from this study should be targeted for future management efforts. And with that, I would like to thank my lab and all my collaborators, those that helped me with all the simulations I had to run, especially when they weren't working and writing functions. And with that, I will take any questions you might have.
Thank you so much, Amanda. So we have a question from Sarah. So by protected areas, are we including the strategy of excluding managed bees within several kilometers of the borders of defined areas? So in effect, are you creating exclusively wild bee zones? So given the multiple stressors, this would seem necessary.
So these protected areas would just be areas where, so normally it would be areas like parks that should be created. So that's what this systematic conservation is designed to do. But these could also just be areas that we target for conservation efforts. So something like limiting managed bees in these areas could be one of the conservation management efforts that could be implemented in these areas.
And from Elaine, how was the impact of climate scenarios on habitat sustainability determined for the different species?
Sorry, can you repeat that?
How was impact of climate scenarios on habitat suitability determined for the different species?
Oh, I see. So we calculated the amount of area or the percent cover of areas on the species distribution map that had at least 50% suitability by just counting up the number of pixels. So if so we set anything lower than 50% suitability on the maxent models to 0, and then just counted up the number of pixels that were remaining.